Hey boys and girls, this is Mr. Bell with Mr. Bell's Math. Today we're going to start talking about percents. Alright, matter of fact, our video is entitled Understanding Percents. Okay, so let's start understanding them. Our essential question, or what I want you to know by the end of the video, is how can you write a ratio as a percent? And this little symbol here is the representative for percent. So whenever you see that, you're talking about percents. Okay, so your first question might be, Mr. Bell, what is a percent? Well, guess what? I can't keep it a secret any longer. I've got to tell you guys. A percent is a ratio that compares a number to 100. How do you feel about that? All right, now you can go on living your lives. All right, a percent, literally, the actual literal meaning of percent means per 100, okay, per 100, or you can take it to mean out of 100, okay. So if you have a number, it's out of 100. That's the basis for a percent. So if we look at a given percent, like in this case 17%, and we want to look at what it's equivalent to, okay, because we're talking about ratios, we can say that 17% is equivalent to 17 over 100, or 17 to 100. Or 17, I don't know what I already said, over 100 divided by 100, 17 out of 100. Okay, we can also use the word to and say 17 to 100. And then we can also use 17 to 100 with the colon. So if this looks familiar to you, hopefully it does, because we've already talked about this in our ratios video. So you should at least have an idea of what I'm talking about here. So here's some different ways that we can kind of compare ratios and fractions and percents and hopefully put all this together. All right. So here's an example. It says the free throw ratios for 3 basketball players are shown. All right. So we have player 1, his free throw ratio is 17 out of 25. We have player 2, his free throw ratio is 33 out of 50. And then player 3, his free throw ratio is 14 out of 20. And I'm saying him, but it could be a her. Now, so this first part says rewrite each ratio as a number compared to 100. All right, so that means we're going to have to adjust these ratios to represent numbers out of 100. Then shade in the grid to represent the free throw ratio. All right, so the first one is 17 out of 25. So I want to do something to the 25 to get to 100. Hopefully your mind's thinking, you're like, oh, Mr. Bell, that's super easy. All I have to do is, that's right, multiply by 4. Okay, so if I get the pen and multiply 25 times 4, I get 100. So if I multiply 17 times 4, that is a multiplication symbol I'm trying to draw, then we get 68. All right, so 68 out of 100 is the exact same thing as 17 out of 25, but now we have it out of 100, so we can represent it as a percent, which we're going to do later on in this problem. Okay, so the next thing we want to do is color in 68% on the grid. So I got this big highlighter that I'm going to use here, so bear with me. All right, so that's 1, 2, 3, 4, 5, 6. I'm going to go ahead and color in the 6 first. All right, and I started coloring in that, so I'm going to color in 68, and it goes up to there. So that's about 68, hopefully. All right, let's look at the next problem. It says 33 out of 50. Let me back up there, because I just wanted to use that. 33 out of 50. Okay, so now we need to convert that into a number out of 100. So we need to think to ourselves, all right, what are we multiplying 50 by to get to 100? Well, guess what? We multiply 50 by 2. That's right, 2 to get to 100. So if we multiply 50 times 2, that means we multiply 33 times 2 to get the top number. And that'll give us a cool 66. All right, so now I want to color in 66 squares in my grid. So I'm going to do the same thing. 1, 2, 3, 4, 5, 6. Let me fill all that in, and then we'll go with the 66. That's 2, 4, 6. Yeah, because I got 4 left. All right, let's look at the last one. Last one says I want to take 14 out of 20 and represent it with 100 in the denominator. So what do I multiply 20 by to get to 100? Hopefully you said, that's right, hopefully you said 5. Okay, so we multiply 20 times 5, that gives us 100. So I multiply 14 times 5, and that's going to give me 70. All right, so now I'm going to shade in 70 squares in my grid. 2, 4, 6, 7. All right, I might be going over a little bit. Please don't be mad at me for that. So now we go down to question B. Question B says, which player has the greatest free throw ratio? So the greatest free throw ratio is going to be a high number. All right, so the highest number that we have is 70 out of 100. You know, because now all our denominators are the same, we can make our comparison a lot easier. All right, so the biggest number is the highest free throw ratio. So player 3. Player, sometimes my pen works and sometimes it doesn't. Player 3 has the highest free throw ratio. All right, how is this shown on the grids? Well, I mean, shoot, you can just look at the grids and tell that this grid here has more squares colored in than, say, this grid, which only has this number, and this grid, which has, even though it's 2 less, it's still less than 70. So you can, you know, he has more, just to keep it simple, more squares colored, I guess we could say. Squares shaded. All right. There we go. It's kind of written it right the way. All right, there's an E. Okay, so letter C, it says use a percent to describe each player's free throw ratio. Write the percents in order from greatest to least, or from least to greatest, rather, excuse me. So let's change colors. If I look at the numbers, all I have to do now is compare the numerators. The smallest one is the first one because I'm going from least to greatest. Okay, so the smallest number in this thing is 66. So since it's out of 100, that would be 66%. Okay, next number is 68. Once again, since it's out of 100, it's just 68. And the highest one is 70. So that makes it the highest number. And it's 70 out of 100, so that's 70%. So it says, how did you determine how many squares to shade on each grid? Well, we already kind of talked about it. The grid itself is 100 squares. So if we have, in each of these examples here, I have 70 out of 100. That means I color in 70 of the squares because there's 100 squares. Here I color in 66 out of the 100 squares, so that's what I did. I colored in 66 of the squares. And then, so basically, I guess to answer this question, you could say the numerator tells you which or how many squares to shade in. All right. So the next thing I want to kind of talk about is kind of connecting our fractions and percents, and I want to do it using these percent bar models. All right, because this is kind of helpful. If you can identify a fraction and realize that there's a certain percent that matches it, then you'll be a lot better off. Okay, so it says you can use a percent bar model to model a ratio expressed as a fraction to find an equivalent percent. Okay, so letter A says use the percent bar model to find the equivalent percent for 1/4 or 1/4. So it says draw the model to represent 100 and then divide it into fourths. Well, luckily the model's already drawn. That would take me forever to draw. And then we divided it into 4 equal sections. So we have 1/4 marked on the grid, and we want to know what percentage that is out of 100. Well, 1/4, think about how many, think about dollars. I always want to go to dollars when I'm talking about percent because dollars are out of 100, percent's out of 100. And I'm thinking, what's 1/4 of a dollar? Well, 1/4 of a dollar is a quarter. All right, how much is a quarter worth? 25 cents. Okay, so that means that a quarter is equal to 25%. All right, so and then here in this statement, it says 1/4 of 100 equals 25. So 1/4 of 100%, guess what? 25%. Okay. 25%. So 1/4 of 100 is 25. 1/4 of 100% is the exact same thing, 25%. Okay. It says tell which operation you can use to find 1/4 of 100. Well, the dead giveaway right there is that word of. When you see that word of, and you have kind of two numbers, especially when you're talking about 1/4 of something, it means to multiply. Okay, it means to multiply. I'm just going to write mult. It says then find 1/4 of 100%. So the same thing. If you multiply 1/4 times 100%, you get 25%. Okay, and the multiplication here is easy because you're just doing 1/4. When it says of, you multiply of 100. Okay, so you put it over a division bar, put a 1 under it, and you just multiply straight across. So you got 100 over 4, and then you just divide to simplify 100 by 4. 4 goes into 10. 2 times, that's 8. I subtract, I get 2. Bring that down, that's 20. 4 going to 20 5 times. Okay, so that's how it works. That is how it works. So B says use a percent bar model to find an equivalent percent for, oh, and it doesn't have the number there, but it says 100%. Draw, or for 1/3 of 100%. So it says draw a model and divide it into thirds. We've done that. We got the model drawn. Let me kind of use my pointer here. I got my model drawn. It's up to 100% because that's the whole model. All right. So, and I don't think I mentioned this, but 100% means that's the whole thing. Okay, that's all of it. Whatever it is that you have, that's all of it. All right, and we divide it into thirds. So 1/3 is going to be the same thing. So if we just, now that's a little harder. You can't use money, but if you just divide 1 by 3, that'll tell you that 1/3 is equal to 33, actually 33 1/3, because it's a repeating decimal. It just keeps going on. So down here it says 1/3 of 100 equals 33 1/3. So 1/3 of 100% is going to be 33 1/3%. Okay, let's write that in there. Oops, dropped it again. Hold on, don't go anywhere. My pen keeps acting up. All right, 33 1/3%. All right. It says tell which operation you can use to find 1/3 of 100. Same thing, multiplication. All right, then find 1/3 of 100, which would be 33 1/3. All right, let's move on. So it says you can use certain benchmark percents to write other percents and to estimate fractions. So benchmark percents are basically percent. Hopefully you learned this before. I believe you learned this in the 5th grade. A benchmark percent is a percent that is kind of easy to remember. Okay, like 10%, 15%, 25%. These are all benchmark percents. Okay, so in the diagram here on the board, I have 1/10 is the same as 10%. 1/4 is the same as 25%. 1/3 is the same as 33 1/3%. 1/2 is the same as 50%. 2/3 is the same as 66 2/3. And then 3/4 is the same as 75%. All right, so we're going between 0 and 1 on this number line, and on the second one we're going through between 0 and 100. So in the next example it says find an equivalent percent for 3/10. So what it tells you to do, it says write 3/10 as a multiple of a benchmark fraction. Okay, so if you think about 3/10, if you think here it says think 3/10 is the same as saying 1/10 plus 1/10 plus 1/10. Well, you can simplify that by saying 3 times 1/10. Okay, then you find an equivalent percent for 1/10. Well, you know what that is. 1/10 is the same as 10%. Okay, so then you just multiply. All right, 3/10 equals 3 times 1 over 10, which equals 3 times 10%, which equals 30%. So 3/10 is the same as 30%. So here's an actual example with some numbers. It says 76% of the students at a middle school bring their own lunch. About what fraction of the students bring their own lunch? Okay, note that 76% is close to the benchmark of 75. Well, and since it said about, we can estimate. All right, find the fraction equivalent for 75%. Well, 75% is the same as 3/4. 75% is equal to 3/4. So about 3/4 of the students bring their own lunch. All right, and that's pretty much it. All right, so make sure that you know how to write a percent or write a ratio as a percent. All right, because that question is going to be asked. Y'all have a good day.